often where we see square roots happening of very large numbers. So before we get into that, let's just go ahead and practice what we did yesterday. Okay, so let's go ahead and simplify the square root of 75. Just like we did yesterday, no different. What's my first step?
Find what two numbers go into 75.
Perfect. So what can I multiply together to get 75? How about 3 and 25? 3 is prime, so I don't have to break that one down any farther. However, 25 is not. 25 breaks down into 5 times 5, both of which are prime. So we're good to go there. So 75 is the same as 5 times 5 times 3. Again, we're only interested in identical pairs. So we put 5 and 5 together to get 25. The 3 just stays because I can't put it together with anything. I cannot reduce this anymore. So I go ahead and I take the square root of each of these individually. I know the square root of 25 is 5. And the square root of 3 just stays because I cannot take a perfect square out of that. So the square root of 75 simplifies into 5 times the square root of 3. Another practice, let's go ahead and do the square root of 12. On your own, please. Go ahead and simplify or reduce the square root of 12. Hopefully we went ahead and broke 12 down into 2 times 6. 2 is prime, 6 is not. So we break 6 down into 2 times 3. So when I rewrite this, I have 2 times 2 times 3. I have one matching pair of 2's, so 2 times 2 becomes 4. And the 3 just stays. Then I individually take the square root of each of these because I can't put anything else together. Square root of 4 is 2. And then the 3 stays under the radical. So square root of 12 simplifies into 2 times the square root of 3. Anybody having major issues with those things? Okay, so let's refresh our brains on how we solve some quadratic equations. So for instance, if I have n squared equals 16, the easiest way to solve this, because technically there are more than one, would be to get the n by itself by getting rid of the square that's attached. To get rid of that square, I take the square root. What I do to one side, I have to do to the other. A square root and a square cancel each other out. And I'm left with n equals negative, the square root of 16. I need to reduce that square root of 16, just like we did before. So square root of 16 breaks down into 2 times 8. 2 is prime, 8 is not. 8 breaks down into 2 times 4. And 4 we break down into 2 times 2. So I can go ahead and write this as 2 times 2 times 2 times 2. I put my matches together. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. Uh-oh. I ended up right back where I started. Why? Because 16 is a perfect square. So when I take the square root of 16, I get 4. So on the left-hand side, where I'm actually solving, I end up with n equals positive and negative 4. You probably already knew that the square root of 16 was 4, but I wanted to show a simplification as well, okay? And then don't forget when we are solving, we go ahead and we put these things in our nice pretty curly brackets. Hopefully that's starting to ring a bell for you somewhere. Let's go ahead and do another one very similar to this one. This time I'd like to have n squared minus 9 equals 91. Just like before, I'm going with the shortest way of solving this, and that is to add the 9 over. When I add the 9 over, I get 91 plus 9 is 100. My goal here is to isolate or get the n by itself, so I need to get rid of the square. The only way to do that is to take the square root. A square and a square root cancel each other out. And then I'm left with n equals the positive and negative square root of 100. I already know that 100 is a perfect square, and its square root is 10. If I didn't know that, however, I could go ahead and do the factoring like we did on the previous one, so a factor tree. And then you need to write your answers in the curly brackets. Questions, concerns, or issues so far? Then let's do another one. This time, I have negative 5v squared equals negative 70. It looks a little different, but my goal is still the same. I still want to get the variable v by itself. First thing I need to do is divide out the negative 5 for both sides. When I do, I get v squared equals 14. And I just used a calculator for that. To get v by itself, I need to take the square root of both sides now. A square and a square root cancel each other out, so I'm just left with a v on the left-hand side. And I have positive, negative, square root of 14 on the right-hand side. 14 is not a perfect square, so I need to go ahead and break it down like we have been on yesterday's homework and earlier in the examples. It's even, so I can divide by 2. When I divide by 2, I get 7. Both of these are now prime, so I can't break them down any farther. But I also notice that I have no matching pairs to put together. So this is actually not going to simplify at all. Because I would put 2 and 7 together and it would stay the square root of 14. So it's not going to simplify at all. Okay, so we just leave it as positive, negative square root of 14. And we would put that in our nice, pretty curly brackets. So sometimes you're going to have it where the square root and what's under it does not reduce. That is perfectly fine. If there are no issues with that, we're going to go ahead and move into another example. This example is 9m squared plus 9 equals 891. My goal is still the same. I want to get the m by itself. First thing I need to do is I need to subtract this 9 over. When I do that, I get 9m squared equals 882. I know that's a big number, so you're more than welcome to use a calculator to find that. Knowing that my end goal is to get m by itself, I need to get rid of the 9 that's attached to it. Then I can put into my calculator 882 divided by 9. When I do, I get m squared equals 98. I have an m squared, but I really just want to have an m. So to get rid of the square, I need to square root both sides. Square and a square root cancel each other out. And I'm left with positive and negative square root of 98. But this is not my final answer. I need to see if I can reduce that square root of 98. So what we did on our homework yesterday, I'm going to go ahead and do off to the side over here. 98 breaks down into 2 and 49. 49 is not prime, but 2 is. So 49 breaks down into 7 times 7. 7 is prime, so I cannot break either of those down anymore. So this becomes 2 times 7 times 7. The 2 has no match, so it's going to stay by itself. But I can put the 7s together to make 49. There's nothing else I can put together, so I go ahead and I take the square root of both of those. Square root of 2 just stays the square root of 2 because I can't break that down. But the square root of 49, when you put it into your calculator, comes out to be 7. So this simplifies into 7 times the square root of 2. So down here, I'm going to go ahead and replace the square root of 98 with 7 times the square root of 2. So this leaves me with m equals plus or minus 7 times the square root of 2, which then you will break up and write in the curly brackets like all the other ones. So I have negative 7 times the square root of 2 and 7 times the square root of 2. And then I'm done. Let's go ahead and do another one. So on this one, I'm going to have 2p squared minus 7 equals 191. Just like on the previous problem, my goal is to get p by itself. First thing I need to do is I need to add the 7 over. When I do that, I get 2p squared equals 198. Then I need to divide both sides by 2, which leaves me with p squared equals 99. I want to get p by itself, so I need to square root both sides. A square root and a square cancel each other out. And I'm left with p equals the positive and negative square root of 99. Just like on the previous problem, I'm not necessarily done. I need to see if I can simplify the square root of 99 and all by pulling out perfect squares. So I'm going to go ahead and do what I did before. I'm going to do a factor tree for 99. So as I'm doing this, it's pretty obvious to me that 9 and 11 multiply together to get 99. 11 is prime, but 9 is not. So I need to break that down farther. And I know 3 times 3 equals 9. So now my prime factorization for 99 is 3 times 3 times 11. My only matching pair is this 3 times 3, which comes together to become 9. Nothing else can get put together, so we go ahead and square root both of those. Square root of 9 I know is 3, and the square root of 11 has to stay because I cannot reduce that at all. So then on the left-hand side over here, I can finish reducing. When I do, I get p equals plus or minus the reduced 3 times the square root of 11, which of course we can break up and put into the curly brackets. So I get negative 3 square root 11 and 3 square root 11. And then I'm finished. We have just a couple examples left, and then you are free to do your homework. So our next example is going to look a little bit different than the ones that we've just done. So here I have 5k squared plus 8k minus 18 equals 0. This is a quadratic with 3 terms. I will not be able to factor this, so I'm actually going to have to use the quadratic formula on this one. In order to use the quadratic formula, it has to be set equal to 0, and as many like terms as possible have to be combined. I know I'm good to go because I have 1 squared term, 1 linear term, and 1 constant. Then I assign my values. So my a value for the quadratic formula is a number that's in front of k squared, and that's 5. My b value is a number in front of k, which is 8. And my c value is the constant on the end, which here is negative 18. I can go ahead and I can take that and put it into my quadratic formula. In case you don't remember what your quadratic formula is, it is negative b plus or minus the square root of b squared minus 4ac. And then all of that is over 2a, where a, b, and c are the coefficients pulled from our quadratic equation. So I'm going to go ahead and do the quadratic formula for this quadratic. And that leaves me with x equals negative 8, because my b term is 8, plus or minus the square root of 8 squared minus 4 times my a value of 5 times my c value of negative 18, and then all over 2 times my a value of 5. So I just went ahead and plugged in those a, b, and c values that I pulled from my quadratic. From here, I'm going to go ahead and simplify. So I get negative 8 plus or minus the square root of 8 squared is 64 minus 4 times 5 is 20. 20 times a negative 18 is negative 360. Since I already had a minus there, it became minus negative 360, which then becomes a plus. 2 times 5 is 10. Simplify this some more, so I get x equals negative 8 plus or minus the square root of 64 plus 316 is 424 all over 10. But I'm not really sure where I could go from here because I don't want to get a decimal. I want to leave this in exact values, which means I'm going to have to simplify this 424 that's under the square root. So I'm going to take that and I'm going to do what we did on yesterday's homework. I'm going to go ahead and do my factor tree. So I have the square root of 424. Clearly that is even, so I know 2 can come out of it. When I do that, I get 212 left. 212 clearly is not a prime number, so I break it down farther, which leaves me with 2 and 106. Break 106 down farther to 2 and 53. Is a prime number, so there's nothing else that I can do with it, which means I can just go ahead and write my prime factorization. So I had 1, 2, 3 2s, and then 153. I go ahead and I put my pairs together. I have 1 pair of 2s, which multiply together to become 4. The 2 and the 53 then are stragglers. I'm going to go ahead and put them together just because I know they will eventually. But that isn't something that I can take the square root of, okay? Nothing else can get put together, so I go ahead and square root both of these. Square root of 4 becomes 2, and I cannot reduce the square root of 106. So then I'm going to take this, and I'm going to replace the square root of 424 with this reduced 2 times the square root of 106. So then this becomes x equals negative 8 plus or minus 2 times the square root of 106 all over 10. The good news is we are almost finished. All I have to do now is simplify this and then put it in curly brackets. When I say simplify, I mean I need to look at the 3 whole numbers that are present that are not under square roots. And I need to ask myself, is there something I can divide out of all 3 of them? Here, I can definitely take a 2 out of each of them because they're all even. So I can take a 2 out of -8, a 2 out of 2, and a 2 out of 10. When I do that, I'm left with -4 plus or minus 2 divided by 2 is just 1. So I have 1 in front of the square root of 106. You don't always have to write that. And then 10 divided by 2 is 5. This is as reduced as I can go. So this is what I'm going to go ahead and put in my curly brackets. 1 positive and 1 negative version. So I have -4 minus the square root of 106 over 5. And I have -4 plus the square root of 106 all over 5. And that is my solution set for this quadratic. So it is the exact same as when we did quadratic formula before, except instead of getting a decimal, we want a reduced radical. Let's go ahead and do another one. On this one, I have 4b squared minus 8b plus 1 equals 0. This is already set up perfectly for the quadratic formula because it's already set equal to 0 and simplified. So I pull out my a, b, and c values. And then I plug those into my quadratic formula. So I get x equals a negative of -8 plus or minus the square root of -8 squared minus 4 times my a value of 4 times my c value of 1 all over 2 times my a value of 4. From here I can simplify. When I do, I get x equals a positive 8 because a double negative makes positive, plus or minus the square root of -8 times a -8 is 64, minus 4 times 4 is 16, times 1 is still 16, and then 2 times 4 is 8. I can go ahead and do 64 minus 16. When I do, I'm left with 48 under the radical. I am almost done, but now I need to go ahead and simplify that square root of 48. So I'm going to grab that and I'm going to take it off to the right-hand side, and we're going to go ahead and simplify it like we have been. So I have the square root of 48. This is even, so I know I can take 2 out of it, which leaves 24. 24 is even, so it becomes 2 and 12. 12 becomes 2 and 6. And then 6 becomes 2 and 3. So my prime factorization is 2 times 2 times 2 times 2 times 3. So I had 4 2s, and I had 1 3. From here, I put together matches. 2 times 2 is 4. 2 times 2 is 4. And then the 3 on the end is a straggler. There's nothing I can combine it with. Put together matches again. 4 and 4 becomes 16. The 3 again just stays on the end. I can't put anything else together, so I go ahead and take the square root of each of these. Square root of 16 is 4. And then square root of 3 just stays the square root of 3. So I'm going to take this 4 square root of 3 and replace the square root of 48 with it, which leaves me with x equals 8 plus or minus 4 times the square root of 3 all over 8. Our last step then from here is to simplify if possible. So is there a number I can take out of 8, 4, and 8? Well, yeah, I could take a 4 out of each of those. 8 divided by 4 is 2. 4 divided by 4 is 1. And then 8 divided by 4 is 2. So I'm left with 2 plus or minus the square root of 3 all over 2. And I can go ahead and break that up into 2 different values and put it in my curly brackets. So I have 2 minus root 3 all over 2 and 2 plus root 3 all over 2. Any questions, concerns, or issues with that one? Okay, I think we're gonna go ahead and do one more. And then that will be the end of it, I think. Because that should be plenty of examples. So the last example I would like to do is 11x squared plus 3x equals 9. As I'm looking at this, this is not ready yet to be put into the quadratic formula because not everything is on one side of the equal sign and it's not set equal to 0. So the first thing I need to do is subtract the 9 over to the left-hand side. When I do that, I'm left with 11x squared plus 3x minus 9 equals 0, which means I can go ahead and pull out my a, b, and c values, which will then allow me to plug them into our quadratic formula. So when I do, I get x equals negative 3 plus or minus the square root of 3 squared minus 4 times my a value of 11 times my c value of negative 9, all over 2 times my a value of 11. I go ahead and I simplify. So I get x equals negative 3 plus or minus the square root of 3 squared is 9 minus 4 times 11 is 44 times a negative 9 gives me what, 396, I think. Yeah, 396. But it's a negative 396. And then all over 2 times 11, which is 22. A double negative becomes positive, which means I can go ahead and simplify what's inside that square root right now. When I do, I get x equals negative 3 plus or minus the square root of 405, because 9 plus 396 is 405, all over 22. Just like before, I need to see if I can simplify that radical 405. I go ahead and I do that work over here, just off to the side. 405 is not even, so I can't take a 2 out, so I need to find something else. It's pretty clear to me that a 5 comes out of it because it ends in 5. When I do that, I'm left with 81. 81 is not prime, so it can break down farther into 9 times 9. 9 is not prime, so it breaks down farther into 3 times 3. Do that for both of these. 3 is prime, so I'm done. In my prime factorization, I have 4 3s and 1 5. I go ahead and I identify my matches. Well, 3 and 3 becomes 9. 3 and 3 becomes 9, and then 5 just stays. I can put together my 2 9s to become 81. Square root of 81 and the square root of 5. Square root of 81 is 9. And then the square root of 5 just stays. So I bring that back over here, and I replace the square root of 405 with 9 times the square root of 5. So I have negative 3 plus or minus 9 root 5. all over 22. Once I've gotten this far, I look to see if I can simplify this farther. So I ask myself, what number comes out of -3, 9, and 22? The answer is there are none. There's no common factor between those three terms, so I cannot simplify that, which means that this is my answer. I just need to put it into my curly brackets and split it up into two problems. So -3 minus 9 root 5 over 22, and -3 plus 9 root 5 over 22. And then I'm done. So this is what your homework is. It's a little bit of all of this, I believe. If you have any questions, of course, I will stay on the Google call. I encourage you to also stay in the Google call. That way you can ask me questions. Aside from that, your homework is on Canvas, and as soon as this video is done uploading, I will post it onto Canvas as well. Does anybody